So right now we'll be discussing how the unpackaged service works in Talawa plugin architecture. The unpackaged service is only supposed to unpackage or unzip the packaged plugin from the plugin fetched from our object storage Minio or AWS S3. The first thing the unpackaged service will do is a client will hit the unpackaged service and will try to fetch the plugin code files from an unpackaged service. The unpackaged service will first check that do I have these files in cache. For example, when you go to VS Code and when you launch vscode.dev, which is a web version of VS Code, this is what I went through. You see there's a package.json request, network request going, and this request hits this request URL. If you take this and copy and paste this URL right now, you will see a package.json file going here. If you pretty print it, it will look better. So this is how a package.json file is this is how it looks. Now let's say I remove this and just figure out extensions, and so now you see a different, you see all these, this is extension is a folder and you can see all these subfolders and under extension. Let's go to dist folder and you will see dist, you will see a dist folder. You can see spec.node file or something like that. So let's go to spec/node. Let's see what we have in spec.node. We have another file. It's a JS dev container file, JS file. So you can see that a file tree kind of has been stored in this unpackaged service of VS Code. This we will be replicating a lot like this in our unpackaged service. So the first thing that the unpackaged service has to do is it has to look for these files in the cache. Our cache will be a simple Redis key value system. The key for a key will be stored like slash extension, and slash extension will have a value like this. A key will be stored like slash package.json, and it will have a value like this. The whole JSON string JSON thingy you see here. This will be the key and this will be the value. So this is how in Redis or in any cache, something very similar we can implement, so that now for the first time when the requester is hit for a particular file or a plugin code, then it will take some time, because then you will go to file not found in cache and you will try to fetch this file from min.io, right? This file from min.io will be fetched and then it will be unpackaged, and then it will be given to cache so that you can store it for the next time. It can be more better. The latency will be very less, and then it will also directly go to the client so that the client can receive this file, the particular code file that the client has requested. So in this way we make sure that the latency hit for any plugin code file, any requested file, is as minimal as possible. And even better approach we'll implement is that whenever a client fetches a plugin code file like this in this request, the client also should store this request in its own cache storage. To show this how this is done in real life, let's see the application of this VS Code, and you can see cache storage here. Let's go to cache storage and let's see something. You can see slash extensions chat.json, and if I download an extension right now as a live demo, then you can see an extension like this. Let's take a popular YouTuber that has an extension. I hope you know this YouTuber. So this is an extension we have downloaded right now, and let's see if we can see this extension in the extension cache storage. So you see there's a extension cache storage here, code or choice. This is the extension that we have downloaded. This is the extension we have downloaded, chai theme light chai.json, and this is the extension we have downloaded, and you can see that it has cached it. First, the network request went and got these particular files, like see dark chai.json has been gotten from this particular URL. This is the unpackaged service of VS Code again, and then it has been stored in a cache, and you can see dark chai.json has been stored in a cache of in memory browser cache. And now whenever a VS Code needs to access dark chat.json, they will just hit their cache. They won't hit the request and make the latency even bad. They'll make sure that they cache this, and we will also implement something very similar, that we will cache this and we will store it in our application, so that every next time if we want any particular file and if we don't have it on cache, then only we will request it in our unpackaged service, or otherwise we won't. This is how we can minimize latency. and you make, and this is how it is also done in the real world. Once we have cached here and we'll also cache it here, there will be very few hits to the min.io, and hence it will require very less unpackaging. So this will help us. Now the client only needs to do a get request for a plugin code file. The unpackaged service will, as usual, first check whether the key exists in the cache or not. If yes, then we provide the client with the file. If not, we fetch the file from the storage of the plugin store. This fetched file is packaged file, which is extracted or unzipped in similar terms, and then provided to the client, where we store the key value pair in the cache as well. The client can do these kind of requests that like we just saw, and we can easily get these files. So for the first time, because we will have to fetch from min.io, we will have to unpackage it. It will take a lot of time. It might take 1 to 3 to 5 seconds. But after that, it will not take more than 100 or 300 milliseconds, because we are not even fetching files from the unpackaged service. We are fetching it from our browser cache, and even if we fetch it from the unpackaged service, it will still take lot more than 300 milliseconds. The recommended cache will be, of course, Redis, as it is open source and is already implemented in our Talawa application. So this is a very important service in our Talawa. If unpackaged service has been implemented very well, it will be very scalable to build such an application.